welcome to True Projects. In this video, we are going to explain about the project which is automatic blood cell detection based on advanced YOLOv5s network. So before getting into the execution, first let us understand what is the project about. So what is this complete blood count or CBC in short? It's a key diagnostic test that provides crucial insights into a person's health by assessing three main components of the blood which are red blood cells, white blood cells and platelets. So RBCs that are red blood cells, they carry oxygen throughout the body. So they are responsible for carrying oxygen throughout the body. Coming to WBC, that is white blood cells, they play a pivotal role in our immune system, helping to defend against infections and diseases. Coming to platelets, on the other hand, they are crucial for blood clotting, which is important for wound healing. So when doctors look at this CBC report, that is complete blood count report, they pay close attention to counts of these cells. If any of these are abnormal, it can signal potential health problems. For instance, low RBC count might indicate anemia, while an elevated WBC count could suggest any infection, or even something more serious like leukemia. Therefore, having accurate information about these blood components is essential for making timely and informed medical decisions. When it comes to analyzing blood cells, traditional methods such as hemocytometers, that is hemocytometers and hematology, we have hemocytometers and hematology analyzers can be quite cumbersome. So these approaches often require manual validation, which not only makes the whole process take longer, but also leaves room for human error. But they rely heavily on the specialized skills of the person doing the analysis. And the other challenge is that high density of cells in the blood smear images, which adds a layer of complexity that makes accurate analysis even more difficult. So, this is where a strong need for automated solutions that can handle these tasks more efficiently and accurately. Fortunately, we have advanced deep learning models. So, these deep learning models are showing great promise in this area. These technologies can significantly enhance detection accuracy and speed up the diagnostic process, ultimately leading to faster and more reliable results for the patients. So, moving on to tackle all these challenges in this proposed system, we have taken YOLO V5S into the consideration, which is one stage network, and made some significant enhancements to automated detection and classification of blood cells. YOLO V5 is nothing but it is you only look once version 5. So, this is really important because traditional methods for analyzing blood cells can be quite slow and labor intensive, often depending on the expertise of the analyst. So, to tackle this, we have integrated some of the advanced components into the model. For example, we have added transformer and bidirectional feature pyramid network, that is BIFPN. So, the transformer helps to improve the way the model process features, while the BIFPN enhances the connections within the network. So, this combination allows the model to handle features more effectively, enabling it to capture both broad and intricate details within the image of blood cells. Essentially, these improvements help the model more intelligently, leading to better and more accurate detection and classification of blood cells. And we also have added convolutional block attention module, that is CBAM, to outputs of the NEC network. So this is smart in addition because it helps the models focus on the most important features in the images, both in terms of spatial arrangement and also their channel information. So by honing in on those critical aspects, the model can identify cells more accurately. On top of that, here we have included efficient intersection over union, that is EIOU, which improves how well the model can locate the cells in the images. With these changes, we are significantly boosting the model's overall precision and efficiency. This means we are providing a strong automated solution for analyzing blood cells, which is crucial for reliable clinical diagnostics. Ultimately, these enhancements makes it easier and more accurate for healthier professionals to diagnose conditions based on blood cell analysis. So, as the extension of this project, we are incorporating some of the latest advancements of the object detection algorithm. Specifically, we have implemented the upgraded versions of the YOLO, which are YOLO V5X6 and along with the newest iterations of the YOLO, which are YOLO version 8 and YOLO version 9. So these enhancements significantly improve our ability to analyze and detect objects, which is critical for the blood cell analysis. Moving on, we also have developed a user-friendly front end using Flask framework. So this is really important because it allows users to interact within the system more easily. And here we have included features for user testing and authentication to ensure a smooth and secure experience. Overall, this extension is designed to make the blood cell detection and analysis process even more effective in clinical settings, providing a more comprehensive and interactive tool for healthier professionals. Moving on to the implementation of the project. So, first, we have started by importing the necessary libraries and packages that are essential for image processing, model training, and building the web application. And then involves loading the blood cell images from the dataset. After loading, we visualize the images to understand their content and the quality. And then we do basic image processing where the images are transformed into a blob format to prepare them for the model output. And we specify classes of the objects that are blood cells that model will detect. And we set up bounding box coordinates, that is, bounding boxes that will be used for localizing the blood cells in the images. And in the next step, it involves in converting images, that is the data, into a format that can be easily manipulated using NumPy. And then we load the architecture of the pre-trained model which has already been trained on the similar tasks. And then we identify the layers of the network from which we will get the predictions. And then we do again basic reprocessing where we link the images with their corresponding annotations for better training. And we convert, since the images are often in the blue, green, and red format, we convert them to red, green, and blue format, that is RGB, which is standard for the most processing tasks. So here we convert images from BGR to RGB. Coming creating the mask, here we create a mask to highlight the areas of interest in the images. And the images are resized to fit the model's input dimensions. So coming to data augmentation, so this step involves applying random transformations to the images to improve model robustness. And we rotate images to simulate different orientations of the blood cells, and we add additional transformations that are applied to further enhance the diversity in the training set. Then we ensure that all the necessary packages and dependencies are installed for the project to run smoothly. And then we ensure that we process the data based on YOLO family. So this involves configuring the data set and images specifically for the YOLO architecture. And then we define the architectures of the model, incorporating improvements and the components necessary for effective blood cell detection. And then the model is trained on the prepared dataset where it learns to identify and classify blood cells based on annotations provided. After training, we save the best performing model to use for future detection tasks. And as a user friendly interface, for building a user friendly front end, it is we have used Flask framework, including registration and login setup that supports the SQLite database for database management. And then users they will be uploading the front end images of the blood cells for classifying and detecting blood cells based on the user input. And that user input will be pre-processed at the back end to prepare it for detection by the model, and train model will be fed to the image to give the detection. Finally, outcome will be displayed through front end where blood cells will be detected. Coming to the algorithms used, these are the algorithms implemented in the project to execute. So this is the proposed model, and these are the extension models that are used to detect the blood cells in the images. Moving on to the requirements. So to implement this project, we need basic hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them, how will they be used in the project. So coming to sample folder, here we have some of the test cases that we will be using in the front end to detect the blood cells. Come back. Coming to static folder, in this folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And coming to this app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have model file which contain the algorithm information. This will be loaded into the project code during runtime of the application. So this is notebook file, which is a Jupyter notebook file, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. Here in the first three folders, we have the dataset in it. Let us open the first YOLOv5 folder. So here we have two subfolders. One is train and the other one is valid. Let us open the train folder first. Here we have two subfolders. One is images and the labels. Let us open the folders. Let us open the image folder. So here we have total 751 blood cell images. So we will be using all of these images to train the model so that they will be able to detect the blood cells. Coming to the labels folder, let us open it. Here we have files containing annotations or labels for the objects in the corresponding images. Here, each label file represents each label file it corresponds to an image file in the image folder, providing object locations and providing details about the image and also the classes within the image. For example, the first annotation file, it corresponds to the first image in the image folder. It corresponds to this image. So it provides details and object locations and classes. Similarly, for the second image, we have the corresponding label file. So for the total 751 images, we have total 751 label files that are annotation files. So let us open one file, for example. Here, these label files, they follow the YOLO format where each line represent. So here, each line represents a detected object. So each line represents a detected object. So here, each line specifies object class index and also followed by its bounding box coordinates. So here, the first number we have is the object class index and it is followed by its bounding box coordinates. So this is the X limit, this is the Y limit, this is the width, and this is the height. So 2 refers to one type of blood cell, 1 refers to another type of blood cell. So total we'll be having 3 blood cells. One is red blood cell, white blood cell, and platelets. Let's minimize this. Similarly, we will be having in the all other files also. Get back. Similarly, we will be having in the validation folder also. Here in this, we will be having images and labels. So the images and the label files that are annotation files which are there in the train folder, we will be using them to train the model, and the images and annotation files which are there in the valid folder, we will be using them to evaluate how well the models have performed. So let's get back. Now let's execute. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So now using the command cd followed by the space, paste the copied path and now click on enter. So this command will change current directory to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. We have entered it wrongly. Just give me a minute. Let's enter it again. Now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So it is taking a while. Just wait. So here we got. So this is the local host and this is the port. So web application has been hosted at this particular link. So copy this link provided by the Flask framework and paste it in any web browser. I've copied the link. Open any web browser and paste the link there. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser. This is developed using Flask framework. So now click on register. We need to register first and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. We have logged in successfully and we are redirected to detection page of the project. So here you can see a choose file button, right? We need to click on that for uploading the images. So let's click on choose file. So these are the images that we will be using them as the test cases. So let us upload them. Let's upload the first image, which is in the sample folder. Click on open. Image has been loaded. Now upload it. The image will be processed at the back end and then trained model will be giving the predictions. So here we got the prediction. Here, if you observe, there are three types of blood cells detected. One is red blood cells, white blood cells, and we also have platelets. If you observe, more number of red blood cells are detected than the white blood cells and the platelets. And here also we have the class name, that is the label given to that particular detection, that is that particular blood cell. So here it has been given name as white blood cell, here it has been given as red blood cell and platelets. It is white blood cells are drawn with the white color bounding box, RBC is drawn with the red color, platelets is drawn with the red color. RBC is with the yellow color, platelets with the red color. So here we also have a probability score. So it means that it is how accurate the model is. It's a confidence level that how accurate the model is in detecting this particular RBC, either WBC or platelets. Let's try uploading some more images. Click on choose file. Let us upload this image. Click on upload. So here four cells are detected. Two are red blood cells and other two are white blood and platelets. Here, if you observe, RBC in the yellow color bounding box, WBC in the white color, platelets is in the red color. Let's try uploading some more. Let us upload this image. So here we got the prediction. So here, if you observe 1, 2, 3, 4, 5, 6, 7, 7 RBCs are detected, 2 platelets are detected, and 1 white blood cell is detected. So by this, doctors, they will be able to analyze, they will be able to count how many RBCs they have, how many white blood cells they have, and how many platelets they have. By this, they will observe the abnormalities in the blood cells. Let's try uploading some more images. So let us upload this image. Now upload it. So here multiple platelets are detected, multiple RBCs are detected, and one white blood cell is detected. We also have their probability scores along with the class labels. Get back. Let's try uploading the last image. So let us upload this image. So here, if you observe, there are multiple platelets, multiple RBCs are detected, and one white blood cell is detected. So this is how we need to upload the file, and then we will be getting the detection. Now let's check with the graphs. So click on graph. So here we have the graphs. This is the precision recall curve graph. Here we have FN score graph, where on x-axis we have confidence score and on y-axis we have FN score. And here we have confusion matrix. This is the precision comparison graph, where on x-axis we have precision score and on y-axis we have the algorithm names. Similarly, we have for recall graph. So this is also a metric used to measure the detection models. And here we have mean average precision comparison graph. Mean average precision is a metric used to evaluate the detection models. So here on x-axis we have mean average precision and on y-axis we have the algorithm names. Now let's log out. In this way, just by uploading images to the system, that will be processed at the backend, and the trained YOLO model will be giving the detections of the blood cell. This will be helpful for both the doctors and also patients to take the diagnosis early. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.